So welcome back. I'm going to jump back into fractions, and we're going to talk about multiplying fractions a little bit. You can draw pictures of this, but it's not as easy to do multiplication with pictures. But you could say, well, 3/4 of a rectangle. 3/4 kind of means to divide it into 4 equal pieces. So 3/4 would mean to take 3 of the 4 pieces. So that's that meaning of fraction concept. So 3/4 kind of means 3/4 of a whole. But now you actually got to take 2/3 of that. So to take 2/3 kind of implies to cut this in out 3 pieces. And I get to take 2 of those pieces. So what we can kind of see here is my new shape now has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces in it. And I've actually taken 6 of the 12. So this becomes then 6/12. And you also can kind of see that that fraction reduces on down to 1/2. I can divide the top by 6 and get 1. I can divide the bottom by 6 and get 2, so it simplifies down to 1/2. So there's a way of actually modeling it, but what we've learned, though, it's actually much easier if we just follow these basic steps here. Cancel like factors and multiply straight across. So if I want to multiply 3/4 times 2/3, what I have essentially is 3 times 2 on the top. That 4 can break down into 2 times 2, then I have that times 3 there. So I actually have a 2 times a 2 times a 3 on the bottom. So what I have is some factors I can divide out. So canceling kind of implies dividing out like factors. So if I divide out like factors, 2 divided by 2 would turn to 1. And again, when you multiply by 1, that just falls out of the problem. So it just kind of, as we say, cancels out of there. So what's left then is 3 is the only thing left on the top. Actually, take that back. We can also divide out a 3, can't we? So now there's nothing left on top. So as a placeholder, the 1 just remains. There's nothing left there to multiply by, so the 1 just stays put. And the only thing left on the bottom is a 2, so that changes to that 1/2. So you can what we call cancel out like factors. So if I look at 8/7 times 7/10, if I want to, I can just break that 8 down into its pieces. Again, I can use that prime factorization strategy. That 2, 3, 5, 7, 11. Because anytime I think of factors, I may be able to use prime factors as a methodology, as a strategy. So 2 does go in 8 4 times, 2 goes in 4 twice, and 2 goes in 2 1 time. The 10 does also break down, so let's break that guy down. 2 goes into 10 5 times, and 5 goes into 10 1 time. And again, these steps could be mental steps. So what I have on top then is 2 times 2 times 2 for that 8 times 7. On the bottom you have 7 times 2 times 5. So what I'm going to do now is cancel out my like factors. So the 2's divide out, the 7's divide out. Now we just multiply straight across. So 4 times 4 is 4, and the only thing left on the bottom is a 5. So nothing really to do on the bottom. So the answer becomes then 4/5. So if I look at this example, I have -2 and 2/3. Let's make these look like fractions to start with. So 3 times -2, -6, and that 2. Actually, it's probably easier to leave the negative out. 3 times 2 is 6, plus 2 is 8, so that's going to be -8/3. 4 times 10 is 40, plus 1, so it's 41/10. So that 8, we know it breaks down into 2 times 2 times 2. That 41, 2 doesn't go into 41, 3 doesn't go into 41, 5 doesn't go into 41, 7 doesn't go into 41, 11 doesn't go into 41. So what that's probably telling me is 41's prime. So 41 itself is prime. So I have a 3 on the bottom, and I think we've already broke that 10 down as well. That's a 2 and a 5. So now I want to divide out my like factors. So the 2's divide out. I don't see anything else dividing out. So I'll multiply straight across. 4 times 41. Oops. 4 times 41. Because 2 times 2 is 4 times 41. That would be 164. And there's a negative there. So negative 164 over 15. And again, in algebra, we just keep that as an improper fraction and leave it at that. Okay? So there's a little bit of strategy about multiplying fractions. They're actually fairly easy. Just cancel and multiply. Stay tuned.